Okay, now let's see this question. This question came in GATE 2016 for 1 mark. The question is, let G be a weighted connected undirected graph with distinct positive edge weights. If every edge weight is increased by the same value, then which of the following statements is or are correct? That is true. So the first statement is minimum spanning tree of G does not change, and the second statement is shortest path between any pair of vertices does not change. So this is quite an easy problem, but the only trick is if you don't know the answer already, then it might be a little bit tricky. It is actually the fact that for such a graph, the minimum, if we increase all the edge weights by the same amount, then the minimum spanning tree does not change, but shortest path might change. So P is correct and Q may or may not be correct. So the only thing which is guaranteed to be true is P only. So A is the answer, P only. But let's brush up a bit and try to understand why this might happen. Okay, so a particular graph is given. Okay, so let's say any graph is given, and let's say 1, 2, 3, whatever is there, and let's say we increase all the edges by some amount. Let's say we increase all the edge weights by 2. So 1 becomes 3, 2 becomes 4, 3 becomes 5, something like that. Okay, now just try to understand that when we are talking about minimum spanning tree, then whatever the algorithm, let's say one of the algorithms we are trying to apply is Kruskal's algorithm, then intuitively we can understand that the minimum spanning tree is not going to change. Why? Because in Kruskal's algorithm we are going to sort all the edges, right? So 1, 2, 3 we are going to sort, and we are going to pick the edges starting from the smallest to the biggest. But we understand that if we increase all the edge weights by the same amount, so here we are doing plus 2 plus 2 plus 2 for everything, 1 becomes 3, 2 becomes 4, 3 becomes 5, but the relative ordering, that is the sorted order, still remains the same, right? So when we apply Kruskal's algorithm to the new sorted list, then again we are going to pick the same element, same nodes in that particular order. Okay, so MST is not going to change. The one more condition is like that, if picking a particular node, sorry, picking a particular edge, these are edge orderings, right? So picking a particular edge, if that forms a loop, then we don't have to pick that edge. But we have not changed the topology of the graph, right? So what happens is that if it was earlier forming a loop, then it will be forming a loop in this new list also. Okay, so we don't have to worry about that. So we can safely say that minimum spanning tree is not going to change, and that's why P is definitely correct. Now let's understand what can happen for shortest path between any two pair of vertices. Okay, so let's try to understand by an example. The claim which I am making is that the shortest path between any two vertices may or may not change. So it may change in some situations. So the thing is that it is not going to be a valid statement for all cases. Let's understand by a example. So so let's say this is 1, this is 2, this is 2, and this is 4. If that is the case, and we transform our graph by adding 2 to everything, all the edges, so it becomes 3, it becomes 4, and it becomes 6. But let's say this is the direction. Okay, but here they are saying undirected. Okay, so let's work with non-directed edges only. The same thing will apply, doesn't matter. Okay, so what I am trying to say here also. Okay, so what I'm trying to say, let's say we have to start with this vertex and go till this vertex. Okay, here also we have to start with this vertex and we have to go till this vertex. Now my point is that if we are trying to find the shortest path between the pair, and we have decided this pair, let's say, so initially the shortest path was from this way, right? So shortest path is 3. we take this route 1 plus 2, which is 3. But now here we see that here this path cost is actually 3 plus 4, 7, right? But this past cost is the cost of this path is 6. So now this is actually our shortest path, but earlier this was our shortest path. So we see that shortest path might change if we increase all the edges by the same amount. Why this is happening? This is happening because the different paths get changed by different amounts. That is the reason. Since this path, earlier the shortest path, has two edges, so actually they have increased by an amount 4, 2 plus 2, 4. But this path has only increased by an amount 2. So different paths are getting changed by different amounts, and that's why this shortest path may or may not remain the same. Okay, so P may not be correct always. So the answer is P only, A.